Hello guys, welcome to my YouTube channel. Today we're going to learn about inverse Laplace transform. In the previous video, we learned about a Laplace transform where we were given functions f of t and you find the Laplace of those functions and we had f of s, right? But for now, we are going to be given the f of s and you'll be asked to find f of t. And what you're going to do is to find the Laplace inverse of f of s so we get our f of t. So we are saying suppose the Laplace transform L of f of t is equal to f of s. Then the inverse Laplace transform is given by L inverse of f of s, which is equal to f of t. Let's do some recap here. Assuming you have been given the function s squared and you have been asked to find the derivative of s squared, which is going to give you the 2x, right? And you have been asked to find a function that you differentiated to give you this 2x. What you're going to do is to find the integral of that function, right? So you're going to integrate 2x so that you get your x squared back, okay? Or let's assume that you have found the sine of pi over 2, which is going to give you 1. And you want to find the value that you found the sine of it that gives you this 1. What you're going to do is to find the sine inverse of 1 and you're going to get your pi over 2 back, okay? So when you want to get your pi over 2 back, what you have to do is to find the sine inverse of 1 and you're going to get your pi over 2 back. And this one is similar to the Laplace inverse here, okay? So you'll be given f of s. So if you compare this one to the first video, I can see that you were given f of t and you had your solution f of s, right? After finding the Laplace of f of t. But now you have been given the solution and you have been asked to find a function. So what you are going to do is to find the Laplace inverse of the solution to get your function back, okay? And you're going to use this table to solve the Laplace inverse examples here. But before we use this table, let's take note of this one. If you are given two functions, f of s and g of s, and you have been asked to find the Laplace inverse of a f of s and plus b g of s, what you're going to do is to bring our constants out, where a and b are constants. So we bring our constants a and b out. So in this case, you're going to bring this a out, then you find the Laplace of f of s. So the Laplace inverse of f of s, plus we bring our b out and you find the Laplace inverse of g of s. So at the end, you're going to get a L inverse f of s plus b L inverse g of s. Okay, so now let's get back to our table. So in the previous video, we saw that this f of t was here and our f of s was also here. But in this case, we have found a Laplace inverse, okay? That's why they have been interchanged. Now for this table to look so simple for you, let me do it this way. If you remember, we learned from the previous video that if you find the Laplace of a constant a, right? So here we are using a as our constant here. If you find the Laplace inverse, the Laplace of a constant, you're going to get the constant over s, right? In this case, you have been given the constant over s, and they are asking you to find the function, meaning that if I find the Laplace inverse of a over s, I'll get my a back. Also, we learned from the previous video that if you find the Laplace of es per negative at, you're going to get 1 over s plus a. meaning that if I find the Laplace inverse of 1 over s plus a, I'm going to get e exponent negative at. And please don't forget, if this negative was to be positive, here we also change to negative, right? So if it was to be e exponent at, you'd have gotten 1 over s minus a. And if you find the Laplace of t exponent n, you're going to get this n factorial over s exponent n plus 1. Meaning that when you find the Laplace inverse of n factorial over s exponent n plus 1, you're going to get your t exponent n. Now, for this one, it wasn't in the table that we're using to solve equations in the previous video, and I'm going to prove this one. That when you find the Laplace of t exponent n minus 1 over n minus 1 factorial, you're going to get 1 over s exponent n. Meaning, when you find the Laplace inverse of 1 over s exponent n, you're going to get t exponent n minus 1 over n minus 1 factorial. So in the next video, you're going to prove this one, okay? And when you find the Laplace of sine 80, you're going to get a over a squared plus a over s squared plus a squared. And we learned this one in the previous video, meaning that if I find the Laplace inverse of a over s squared plus a squared, I'm going to get sine 80, and that this applies to the rest of the functions, okay? So let's start with an example. We have to find the Laplace inverse of f of s, which is given by 6 over s minus 1 over s minus 8 minus 1 over x minus 3. So here, what you're going to do is to multiply through by our L inverse, which is the Laplace inverse, right? Yes, so if you multiply through by the L inverse, that will show that we are truly finding the Laplace inverse of the functions, okay? Good. Now, we are having the Laplace inverse of 6 over s. Don't forget that we said that if you find the Laplace of a constant, you're going to get a constant over s. Here, 6 is constant, right? So if you find the Laplace of 6, you're going to get 6 over s. But in this case, you're going to find the Laplace inverse of 6 over s, right? So if you find the Laplace of 6 and you're getting 6 over s, meaning if you find the Laplace inverse of 6 over s, you're going to get 6. So our Laplace inverse of 6 over x here will give us 6. And when you find the Laplace inverse of 1 over s minus 8, you're going to get e exponent 80. That's what you're going to get. And when you find the Laplace inverse of 1 over s minus 3, you're going to get e exponent 3t. Okay. So in all, you're going to get 6 minus e exponent 80 minus e exponent 3t. Now, from the second example, we have to find the Laplace of 1 over 2x minus 3. Please, let's know that the coefficient of s here must always be 1, okay? The coefficient of s must always be 1. So if we are to find the Laplace inverse of 1 over 2s minus 3, we have to do something with the coefficient of s so that we'll be able to find our Laplace inverse. Okay, so what I'm going to do here is to factorize 2 out from the denominator, right? So if I factorize 2 out from the denominator, I'm going to get 1 over 2 multiplying x minus 3 over 2, okay? Then I'll bring my 1 over 2 out. I therefore find my Laplace inverse of, sorry, I didn't bring the Laplace inverse here. I'm now going to find the Laplace inverse of 1 over x minus 3 over 2. And this is going to give me 1 over 2 times e exponent 3 over 2t. And please don't forget that our 3 over 2 here is our a, okay? Yes. So that's what you're going to get. 1 over 2 multiplying e exponent 3 over 2t. Now from example 3, you have to find the Laplace inverse of this. 12 over s squared minus 9. And we can see that this one is like the sinh, okay? Sinh t. So let's try to find the Laplace inverse of this function. So the Laplace inverse of this function is going to give us, please don't forget that we said that when we find the Laplace of sinh at, we are going to get a over s squared minus a squared. Okay, but when you check at the numerator here, we're having 12, right? And okay, let me use this one too. Okay, so when you check here, we're having 12 here, and here is 9. But we said that it should be a, here should be a, right? And here should be a squared, meaning that I have to do something with the numerator, because what will come here, or what will come at the numerator, is what I'm going to use, what I'm going to square it here. Okay, now we can write 9 here as 3 squared. Okay, meaning 3 has to come at the numerator, so that will be 3 over x squared minus 3 squared. Okay, so you have to split these two, and we can write 12 as, sorry, you have to split this 12, sorry, we can write this 12 as 4 times 3. Okay, so I'll bring my 4 out, and I'll get my 3 over x squared minus 3 squared. Okay, so that it be in the form of a over s squared minus a squared. Okay, okay, sorry, my Laplace inverse didn't come. So when you find the Laplace inverse of this, you're going to get 4 sinh 3t. 4 sinh 3t. Okay, so this 4 is going to multiply our sinh 3t here. Okay, okay, let's try this one too. You have to find the Laplace inverse of s over s squared plus 25. And this, when you find the Laplace inverse of this function, you're going to get this. Now we can write this 25 as 5 squared, right? So you're going to get s over s squared plus 5 squared. Now let's replace the 5 by a. So I'll get s over s squared plus a squared. You can see that this one sounds like a Laplace inverse of cos 80, right? In this case, our a is 5. So we are going to get cos 5t. Okay, when you find the Laplace inverse of this, you're going to get cos 5t. Now let's solve our last example here, which says we have to find the Laplace inverse of x plus 2 over x squared minus x minus 6. Yes, this is very simple. Yes, it's very, very simple. What you're going to do is, now, so you have to find the Laplace inverse of this. Now, this is a quadratic equation, okay? And you have to find the root of this quadratic equation. You're going to get x minus 3 and x plus 2. I think you can point this one on your calculator. And you're going to get x minus 3 and x plus 2, okay? But when you check out the numerator here, you have x plus 2 here, meaning this x plus 2 can cancel this x plus 2. And you'll be left with 1 over x minus 3. And 1 over x minus 3 is like 1 over x minus a, which is equal to e exponent 80, right? When you find the Laplace of e exponent 80, you're going to get 1 over x minus a. Okay, so in this case, 1 over x minus 3 is going to give you u exponent 3t. Okay, yes. So there's a trial question here for us to try our hands on it. You have to find the Laplace inverse of this. So this one too, let me give you a hint, is similar to the last question that we did. When you check the denominator, it is a quadratic equation. Okay, so try to find the root of it and try check if you get some cancellation of the numerator and the denominator, then you find the Laplace inverse of it. Please don't forget to subscribe, and that's the end of the video. Thank you.